Hello, thank you. Welcome aboard the Tech Genius XY Express. Don't forget to hit that subscribe button and ring the notification bell for your passport to programming in English and Hausa. Thank you for joining us today. So, without wasting time, this is our lesson 8 continuation of Python's data type. So, we are going to talk about float data type. What you are going to learn here, what is float data type, how does float work in Python, the method, the functions, and how to import module. So the meaning of floats in Python, we use it to represent decimal numbers and avoid rounding of errors. That is all, to have accurate and precise and be precise. So what is the floating point arithmetic that the float follows? It follows IEEE, which stands for Institute of Electrical and Electronics Engineers in the world. So precision is all about floats. Let's jump back to our code interactive. So I'm going to explain bit by bit before I test run this. So I want to explain all the details here. So I have to comment this out. I don't want us to run into multiple errors. So just let me highlight and comment it out until we reach the parts. Yes, we are there. Yes. So okay, so here we are importing mass. This is how we import. We call module or library. So this mass is a mathematical function defined by C programming. So that tells you in Python you can optimize C programming. It can work with Python. Just we have access of C library and we are working with it in Python. So but actually in C, this is now how you call the imports. You use include in C programming, which is one of the basics way to learn embedded software engineering. Yes, so we import the mass. We want to have access to this ceiling. This seal is a method in this mass, so you can use alias as well. So but we want to use the method in this mass. There's one of the method called seal. So we are going to return a number that is always greater than what we pass. So this is a float 2.3, so a number that will always be greater than this, which is integer, is going to be 3. So that is all about that. And this truncate, we are going to truncate this 3.8. We are not rounding it up, we are truncating it close to 0. That is going to return the whole part, which is 3. So and we printed this, we are storing this in a variable. We printed this. This is another way. We did not declare the variable, we just pass the whole function inside the print function. So you can take note of that. So there is this one, mod f. We are modifying this. We pass a pi, which is 3.1415. This is a pi, which is a float, and we are modifying the pi. We want to take the integer or the whole number part. This is the whole number 3, and this is the decimal or fractional part. So if you run that program, you are going to see what I explained. So I explained about this seal is going to return an integer that is always greater than what we pass, that is 3 here. Then this truncated, we truncated this close to 0, which is 3, and we printed it here. Then we have the integer, the fractional part of this, the decimal part, which is 0.14, is here, 0.14, and we have the integer, which is the whole number, is here, 3.0. So we are checking if it's finite. So if this number is finite, it's not a decimal repeated number. This is not a decimal repeated number, it's true. So we are getting true here. And we are checking if it's not a number. This is none. This is the method, not a number, it's none. So we check if it's not a none. If it is not a number, we're not passing a number here, it's going to return true. So it's true. So we printed it here, and we are copying sign. This is how we copy sign. If you want to copy this is x, this is y. If you want to copy the y sign, not the number, just the sign, the minus, you want to copy it to x, you can call this copy sign. So it copies the minus and give it back to 2, so minus 2. And we printed it here, and we are checking the flow. the floor here is going to return the whole number. The whole number part is 3, so it's not going to round up. Remember, it's not rounding up. You have to be careful. So that is all. And the f sum, this takes a list, which is another data structure. We are going to talk about that. So a list, we pass a list and we sum. We add everything inside the list here. So we're adding everything inside the list. That is going to be 1 plus 2 3, 3 plus 3 6, plus 4 10. So we have 10 here. In this one, we are checking if this number is equals to this number, or if there's any tolerance. If there's any little difference, it's going to return true, otherwise it's going to return false. So this is not close to this, it's going to be false. So this is it, false. So it's finite, we've talked about that. The square root, we call the mass, which is this dot square. So we take the square root of this 9, which is 3. This is it. We are taking the power. This is the base, this is the power. So the base, which is 2 to the power of 3, is going to give us 8. So this is 8. And log 10, this is log 10 in base 10 is going to give us 2. This is 2. And log 100, sorry, this is log 100, not 10. Log 100 in base 2 is going to give us 6.666. You can do the math to make sure everything is running fine. So this is sine. If you want to, your SOHCAHTOA, sine, cos, tan. So if you want to have access to the sine, you call this, you want to have this manipulation, mass dot pi over 2, and it's going to return it by default in radius, in radian, so we can convert the radian to degree with another method. So that is basically that. We are going to we created a float number here, which is the second part of this presentation, and we are going to uncomment all the remaining functionality, so that we will know what we have here up to. Okay, let's stop here and let's test run this. So this is something that we talked about before. This is how we declare variable for float. So we pass the float we want. This is pi 3.14. We store it in this variable name, my float. Then I'm checking, is this my float dot is integer? Is it an integer? We know integer does not have decimal, so this will return false because this is not an integer. So in this case, integer ratio. So this, we are checking the numerator. This is one way to declare two variables at the same time. So we are declaring the numerator comma denominator, just like the way we did for the fractional and the integer part. So we declare two variables at the same time. We pass, if they have the same value, we'll pass the same value, but because we are using different function as integer ratio, this integer ratio returns the numerator and denominator. So it's going to give you the numerator part, but in this case not in the least fractional. So it's not going to give you in the least fractional numerator the nearest fractional. No, it's going to return the largest. So if you test run this, you are going to see a very large number for numerator and denominator as the index ratio, but we can still simplify that further. So we are converting these floats to hexa. Just call the dot hex normal as you normally do. So you call this dot hex, then this is a hexadecimal, that is base 16 representation. So you are converting it back from base 16 to floats. So you call float dot from hex. So you pass the hexadecimal representation which we store in this variable, then we convert it back. We are going to have our number, which is 3.14152. So we are checking the conjugate if you are dealing with solid or complex number. So you can call this function my float dot conjugate to give you the other parts of the number. So in this case, we are formatting this to 2 decimal place. So you call the format, this is the format, you pass the float number you want, then the decimal, how many decimal places you want, then you print it out. So let's test run this. So we are having 3.14, that is 2 decimal. After the decimal we have 2 digits. So this is the complex conjugate part. This is the hexa, the float number that was converted from the hexa. So that is basically that. We are going to uncomment the last part of this, which is I'm highlighting, and I'm going to stop where the comments is going to reach. So this is too much. Okay, I guess we are here. So this is a little bit long, but in short, I'm going to be as fast as possible. So this is how we declare the variable floats, just like we explained with floats, any number that has decimal. So we check for the is it integer. Just we are still repeating ourselves with more details. In this case, we are adding more description to the comments, telling you what it's doing. And we check the numerator and denominator. I have explained this is another way to declare two variables simultaneously. So you can by putting comma, and they have the same value here, but because of we are using the as integer ratio, so we are checking this is a function that's going to return the numerator and denominator separately to these two variables. So this is hexadecimal. I repeated myself. This is how we converted from hexadecimal to float, and this is conjugate part. This is just what I finished explaining. So in this case, okay, we can also use float. This is 5. You can pass integer. This is integer. You pass integer to the float itself, the float data type. It converted to 5.0. So let's run this. So it's going to convert it to 5.0. This is it here, 5.0, as you can see. So we are checking if it's greater than 0. 3.142 is it greater than 0, is going to return true. As you can see, is true. Is it less than 0, is going to be false. It's going to be false. So that is all about this. So we are converting this int. We are passing float 3.142. We are converting it to integer data type, which is going to return 3. So float to int it has returned 3. It did not round it up, so just give the integer part. So that is we are calling the int data type. So as well as you can call the absolute value. This is how to call the absolute value ABS. Then you pass the flows, that is the non-negative value of that value will be returned to you. So we have come to the end of this slide. So let's continue with our code example. This is your assignment. Okay guys, thank you for joining us. Have a great day. Thank you. See you soon. Okay, take care. Bye bye.